Okay, thanks everybody to join this meeting today of the Data Facades W3C community group. So as usual, we have often invited speakers so we can learn from practitioners in the reference sector about data integration issues and knowledge graphs and semantic web technologies in general. And we can use this feedback to develop our own specifications and our own work within the community group and to test our assumptions and hypotheses. So today I'm particularly excited to have Vladimir Alexeyev from GraphWise. He's is a director
Chief Data Architect, but not
Chief Data Architect. Yes, sorry.
Yeah.
I think I was left to your role in Ontotext. Anyway, Chief Data Architect, which is a perfect perspective to integrate to our collection of feedbacks. So without further ado, I'll leave the place and the board to Vladimir.
Okay, also here is my colleague Arkadiusz Chadzinski, who's a knowledge
Welcome.
graph engineer at GraphWise. And do we have the whole slot for this discussion, this presentation and discussion?
Sorry, can you repeat that?
Do we have the whole slot, or like how long do we have?
I mean, usually we have like the first half, 30 minutes, and then we can have a discussion, or you can take as much space as you want, clearly.
Okay. So I would like to talk about two topics today. One is using simple declarative models to express what you want to be converted. And the second topic is streaming. I don't have a prepared presentation for both of them, but I'll show some stuff from other presentations, and then I'm looking forward to the discussion. Okay, so I'll start with this publication, and let me paste the link to it in the chat here. So it's a simple set of 2 or 3 tools that we have used quite often in GraphWise for archiving of data. And there is an older presentation as well. It's this one, RDF by example. But I think I'll go with the newer one, which is at the Endorse conference. Okay. So I've opened the presentation, and then here this link URL is a short paper about it, something like 10 pages. Okay. And I also will look at this here link, this GIST, which I have called the Crunchbase Challenge. So it's something that I posted to the Knowledge Graph Building community group. And this is an example of a simple declarative model. Okay, so Crunchbase is a knowledge graph or a data set of companies. It has 18 CSV files and about 40 million rows in total. And by using our tooling, we convert it to a knowledge graph that uses 40 million rows. So one row per one graph per row in any one of the CSV tables. The reason we use such a huge number of name graphs is so that we can implement updates, and I'll explain in a second how updates works. Okay, now that is actually already a bit of a problem if the conversion tool is based on Sparkle Construct, like Tarko, and I think also Sparkle Anything. The reason is that in Sparkle Construct cannot express a name graph. But there are cases where you want data to go into different name graphs, right? From one transformation into different name graphs. Okay, so this is how the model looks, and it's a turtle in which you have templated URLs like this, right? Or templated literals like that. or this is again a literal that, however, has a data type attached. So in parentheses, obviously, are fields from the data source. This only works on CSV, okay? But if you have, let's say, 18 transformations for 18 related CSVs, then we usually also concatenate these partial models to see how the overall model looks. And we'll look at that in a second. Then this is a little function that is invoked, or I should say pseudo function, because defining functions in SPARQL is possible, but it takes a bit of doing. I mean, you need to go into Java and declare a class that includes that function and register it and so on and so forth. Even though some SPARQL implementations allow escaping into JavaScript, the GraphDB SPARQL can do it. But in this tooling, it's a simple macro file so that, this gets expanded into a SPARQL bind that does something with this field, like swaps, turns into a proper XSD datetime format. Similarly here, this split one is a macro that gets expanded into, depending on which tool you use, because split returns multiple bindings, right? So it takes the column rows and returns multiple bindings because that column is multi-valued separated by comma. And then the urlify macro examines that phrase and basically replaces punctuation with underscore, maybe lower cases, something. So it turns a phrase, like you can have here, something with spaces, into something that is suitable to use in a URL. Similarly here, right? So we use another split. Maybe that one is on comma, maybe this one is on semicolon or something like this. Now it's also important that the multiple bindings from this variable and from that variable do not get mixed up, and so that you don't produce a Cartesian product of bindings. And do we have anything else? This here macro examines for a set of void values like NA, like not applicable or something like that, and discard such things. And another urlification over here. So these are very simple data operations. Correct the format, like fixed date, or split something, eliminate some useless values, and then either attach a data type or attach a language, which isn't shown here because this database is all in English, or use it in a templated URL. And the reason I like this simple way of expressing things is because here are the 18 individual models for the 18 tables. I mean, I think every node here is a separate CSV that gets processed. Actually, inside organizations, one of the fields, namely the long description, for some reason they put in a separate CSV. So you have two turtles that operate on the same URI. In the subsidiary table for long description, you just have the org UID and the description, but they're displayed in one node because both of them add statements to the same node, right? And then one extra thing that we have in order to produce this total model is a bit of renaming. So maybe over here, the link to entity was not called investor UID, like the primary key of this node. Primary key, I mean the part that is used in the URI. Maybe it was called something else in the table that uses that primary key. So I mean, in relational terminology here, you can have a foreign key that links to the primary key of the table. But in order to show it as a connected graph, I have a simple script that renames some of the fields. So the foreign key that is in this table gets renamed to the primary key over here, so that it is shown as a connected graph. So anyway, my point is that this graph, which is nearly totally connected, except Here we have the hierarchy of industrial sectors. Sorry, where did I go? So here we have a table called category list or categories, and it shows for, I guess it has two fields. One is category list and the other one is category groups list. And it gives you the parent relation. So maybe the bottom level would be legal tech and the parent industry would be legal consulting, right? So because these guys are used somewhere here in the organizations table, but they're used by URI. So for some reason, it shows us if it is disconnected. In fact, it also connects with the data. My point was that by showing it in a total graph like this, which is just the concatenation of the individual turtles of the individual models, we see that the data is interconnected. We haven't, for example, mistyped the URI pattern in one of the transformations. Okay. So this Crunchbase challenge has this total model, and it has an explanation. And now let's look at the SPARQL transform that gets generated. So you remember the organization model, which was a turtle that looks very much like this, right? But instead of variables like this, we have just the turtle pattern for that. So what was it updated on? Last updated on? No, last funding. Here is created at and updated at. Okay, so updated at is literal, which however invokes the macro fixed date and attaches the data type. This gets translated to a variable created at fixed date, whereas created at fixed date is first we apply the fixed date macros, which is just a replace binding. And we generate a new variable called created at fixed date. And then we attach a data type to this and we turn it into uppercase. Right? So these two bindings represent the very simple data transformation that is needed on the column closed on. Sorry, what was it? Last updated on to turn it into a proper RDF data type literal. So we have a bunch of bindings, right, that are generated from the model. Here is, for example, I recognize the urlify function. So it's a replace, and we take anything that is not alphanumeric. This is defined in the macro that implements urlify. This is the Unicode class for letters and also digits. Anything that is not a letter or a digit gets replaced with an underscore. Any sequence of underscore is replaced with a single one, and then we also remove leading and trailing underscores. So we replace any punctuation with underscore and leave any alphanumeric characters, and that's why we have a better part of a URL to use. Okay, and this here is a SPARQL update. It starts with a delete graph because this is a script for OnToRefine, which is an adaptation of OpenRefine, and it exposes tabular data as a virtual SPARQL endpoint. So for every row, you get a binding where every column is represented as a variable code like that, C underscore blah, blah, blah. So actually the first set of bindings I have is convert from this. I don't know why in OnToRefine we have C underscore, but I convert it to whatever is in the model. In other words, I don't want the model to use this parasitic C underscore. And now The first thing it does is this part of the query runs in GraphDB, but this part of the query in the service call runs on OnToRefine. And so we're saying from OnToRefine, find the column, see updated at, and also find the UID of the graph. So I mentioned we use 40 million graphs. There is about 3.5 million organizations, and all of them are called like that. CB graph organizations, because that's the name of the CSV, and then a UID. So we're saying this is the graph that I want to replace. But I only want to replace it using this filter if it is newer than the global timestamp. You see here I fetch from GraphDB a global timestamp recorded at some global node, which is the time of last update. So I'm saying now convert the timestamp as found in the database to something that corresponds to this variable that is found in the row. And if the timestamp of the row is newer than the timestamp of last update, then delete all triples from this graph. And similar in the insert. So we're saying insert graph, and the graph is computed exactly in the same way. It is somewhere over here, right? And there's a filter, and we're saying this update should only happen if the graph is newer than the last update. Of course, initially we seed this global triple with like 0, 0, 0, 0. So we're saying data has never been updated. And the first run will convert the complete Crunchbase dump of 40 million CSV rows, which happens at about 40,000 rows per second. And then when you get the weekly update of Crunchbase, we use this here logic to only address the graphs where there is a change. And that happens, you know, if a complete Crunchbase conversion takes 40 minutes, a weekly update takes a minute or so. Right? And this is, I think, described in this 10 pages paper and in the respective presentation. Okay, now I'll show something from a current project. So it's a CSV of meta ontology, right? So every row defines a property and the class to which this property should be attached. The very first thing we're doing is we're saying split the column class because it is multivariate, right? And we attach something that is computed from two columns, prop and prop shape. So we make, in the meta ontology, we have an attachment of a property to a class that happens through SHACL. And it's similar constructs to what you have already seen. So here's a fixed triple. Here's a triple pattern. Let me just show how what the macro prop shape does. And this here is, of all things, the C preprocessor. Of course, there are much better ways to do macros. But because I'm an old-fashioned guy and I use make a lot, and that's the tool that everybody has installed. So Curie, for example, or split. Well, because in this case we target Tarko, and Tarko is built on Jena, and that's why we have this, it's called a property function, right? So on the left side is the output variable, on the right side are the arguments, put us a list. So X is the field that we want to split, in this case the column classes, which is a comma separated list of classes, and each one of them carries its own, no, sorry, I first should explain what is that. So this will result in a variable name called classes underscore split. So this hash is the C preprocessor directive to concatenate two tokens. Okay. So inside in the model, we have split of the variable class, and then we call the macro query yQuery because the values of these classes are prefix names, right? For example, meta colon and something, or OTL, which stands for object type library colon something. So here this gets expanded to a special Tarkov function that can convert the colon name by using the active prefixes to a proper URL. Okay. And then this prepends some fixed URI. Of course, there needs to be a defined base for this relative URL to work. And then it says if the second thing is given, then use it. Otherwise, use the first given thing, but after the prefix meta. So we are using part of the variable x, which is the first parameter of the macro, or the whole variable y, and we pick one or the other. So we have two columns that can be used as property URL or property shape URL, I should say, and that's basically a selector, that's a coalesce. And then what else do we have that we didn't see in the Crunchbase example? This is conversion of a string to a language string, right? So we're taking the column IDFS label English, attach the language tag English, and so on and so forth. Okay, this would be a good time to have a bit of a discussion. Do you have questions about this? I call it declarative model. Let me just show the Sparkle query that I get generated. And it's similar. It has a construct part that corresponds very closely to the to the turtle that you saw, right? The very first line of the turtle, it talked about split some variable class and emit a triple SH property based on some other thing. And here we say class, split it, convert it to a query, and then turn it into a URL. And the column prop, but using implicitly a second column called, what was it, prop shape. So the macro only carries the first variable name because of the way this kind of expansion happens. But if you look over here, if you look at the bind defining that variable, we see that it first applies the bind that was declared amongst the macros. That includes that coalesce, right? And then it takes that variable with underscore prop shape and turns it into a URL. So it's a bunch of binds that does the mechanics of passing data around and attaching fixed parts and attaching data types, and then a bunch of triples in the construct clause. Now, Tarkle cannot work with Sparkle updates, right? So these update scenarios that we used for the Crunchbase conversion, which is you have some virtual Sparkle endpoint that returns a binding for every row, and you can implement, if you have a timestamp row, you can implement data update scenarios. And you can slot data into graphs, which is quite important for managing different parts of your knowledge graph in an independent way. But with Tarkle, we are limited to only using, so the result of this construct is a turtle file. Yeah, you can put it into a particular graph if that transformation only produces one graph. But if you have a column that would designate the graph, or you have some more complicated rules that would compute using binds where the graph should go, Okay, so I guess I wanted to make 3 points about you as transformation developers. One is to have a simple declarative way for making transforms, because for me, this turtle is easier to understand and I can generate a diagram out of it compared to the Sparkle query. Second is to have the ability to work with graphs. And third is the streaming. But before I go to streaming, let's have a discussion about what I have shown.
Okay, sure. So, I don't know if anybody wants to start the discussion or make questions. Because so far, from what I've seen, I think it's really interesting to see how important it is to work with layers. So you have like a characterization of the mappings, then you have a set of macros for reuse, and then you have a preprocessor that builds a Sparkle query that you can execute with your own environment. And I also appreciate the fact that often we need to work with different tools. So Tarcol, for example, is very handy for one format, but maybe, as you were saying, you can't use it to insert queries, because then you need to move to another piece of infrastructure. So I think here is really where I think standardization can help.
Just to add a bit on this declarative part. So if you're doing a lot of related transforms, and if you're doing it with domain experts, they like to see the final result. Now, there is a way to visualize Sparkle. I've seen something from SIB, Swiss Institute of Bioinformatics, but it doesn't show you the final shape of data that get produced. It shows you the triple pattern. I mean, it's more complex than what a domain expert would like to see. And examples in the same vein are YARML, a shortcut format for RML, .obda, that's used in on top, a shortcut for R2RML, or I should say alternative, because I think there's no, but on OBDA is very fast to write, I think. I mean, I've seen big transforms, and because you can write the transform of one table on one line or 2 lines. And also similar, Stardock had something called the Stardock simple modeling, something like that. So it's again, you see the shape of output data, and somewhere in there you have some notation to say where are the variables.
Thank you. Yeah. So I think what you're saying is that working with knowledge domain expert, it's useful to have a tool that synthesizes the code of the mapping so that they can review them essentially.
Right.
Yeah, it's much easier to review like a concise template-based view
And
like the one you've shown than clearly a Sparkle query. But then you use Sparkle because your preprocessor is optimized for Sparkle, and so you want to reuse that, I suppose.
Sparkle is really versatile, both for validation. I mean, if you cannot express some validation together with Sparkle, if you cannot express a conversion by Sparkle, therefore you couldn't query it with Sparkle. So Sparkle is kind of like the superset of them all. This same toolkit has a branch, but it's pretty much obsolete, and that for generating RML transforms out of the same sort of models. But because it's not very obvious how to express the field selection in anything more complicated than a CSV. I mean, for the CSV, every variable is one row. I put every transform in a separate file. Don't even need to mention the name of the source. But then you can just literally concatenate a bunch of turtles and generate an overall diagram to validate how the overall thing looks. So yeah, there are other than Sparkle transformers, but Sparkle is a good thing. As a strong following.
Luigi, you
Yeah,
wanted
the
to
other
say something?
important point here is to start from the output that you want. Start from the turtle. I think it is a good practice for developing mappings, since source data might be noisy and comes from integrations. So you have fields which are the mirror of something else. So starting from the output, I think it's a good way to go. And I was wondering how this could work when you have to transform multiple formats, and you would like to use just, I mean, everything in a single transformation, or transformation split in multiple files. So do you have also, have you approached something like this, or do you have any thoughts?
Not in this kit. It focuses on just CSV.
Okay.
I know that CSV being the simplest, there's many ways to skin the cat, right? There's many good approaches. You're right. If you have really heterogeneous stuff, if you need to call out a web service, unzip a file, to find a list of files and then, process each one in turn. And Spark anything really excels in that. So for complex stuff, yeah, my little thing is not a substitute.
I think clearly not. I mean, the FASADX approach gives. I think the really core feature of FASADX is the fact that you can express a number of selectors on a potentially open-ended set of formats. So you have a CSV, you have a JSON file, you have an XML file. You can always express a query using a Sparkle basic graph pattern. This clearly is powerful for everyday use. But of course, when you have to build a whole complex transformation, I really appreciate the fact that you need a number of tools, in the sense like you, for example, the amount of macros you have developed is quite an index of that. And also I'm thinking about the fact that one big limitation now about that we have still after many years of Sparkle is the fact that it's not straightforward to extend it. So you can develop libraries of functions and publish them with a URI, and so that engines can just reuse these functions, and we can have a much richer landscape of operators on Sparkle. Also, I don't think this is a difficult thing to do. So I'm also a bit surprised why this hasn't happened so far. Maybe this is something we should really put our efforts in the next period as a community. And
yeah, two things. Yeah, and Arkadiusz has his hand, but two things just relating to what you saw. The fact that Construct cannot make graphs. And the second question is how to standardize functions that return multiple bindings, the case of splitting. They are posted on the Sparkle Dev GitHub project, the W3C Sparkle Dev project. I don't know when and how this could be standardized, but these I consider to be very basic stuff that is needed. So Sparkle Dev is great because it's not, even though little of it results in Sparkle improvement proposals, it's a great source of information about what is available in different tools, how people do a certain thing, and also to find connected topics.
Yeah, that's a very good point. There is a hands up. Arkadiusz, please jump in.
I wanted to ask actually about the FASADX, which you mentioned, because I started looking into those things recently. And is there any way to separate Sparkle, pure kind of Sparkle construct, out of and FASAD, and provide those two pieces of information separately to the Sparkle anything? Because sometimes it may be desirable to have this kind of Sparkle construct in some sort of reusable way without this necessarily information about FASADX used in some other kind of application storage. So it's easier to manage this rather than having this necessarily there all the time.
So there is, so if I understand your question, I think it's about modularization. How do we split up a large query? So at the moment, there are two ways we do that. One, there is a special feature on Spark or anything, so you can reuse a query directly through a service clause. So for example, you can implement a number of queries and then combine them into a wrapping Sparkle query. I think this is, I'm not sure. I think this is certainly, I certainly experimented this with select queries. I don't know, maybe Luigi has more experience with this feature, but there is a way to modularize the query, like using the service clause. I don't know. And then the other way I do this usually is I split up the workflow in different calls. So because the tool, specifically the command line Sparkle or anything tools, allows to use an input CSV, for example, for variable substitution. So essentially, you can use Bazel variables on a Sparkle anything query. These Bazel variables have like a convention, and that will be replaced by bindings that are taken from for example, a CSV input. So essentially, long story short, you can have a first step when you build a list of, I don't know, for example, identifiers. Then you have a second query that is executed for each of these identifiers and produces, for example, either a third CSV or a graph. And then you can query the graph to do another transformation. So the idea is that the command line tools allows quite flexible combination of multiple queries. So essentially, what I typically do, if I have a complex pipeline, I just break it down into a more like step-by-step workflow, and so that I can better manage the various queries. There are several examples on the tutorials page. If you want, I mean, I can give you a few links now, and then feel free to get in touch. I'll be super happy to give you more information.
We'll get in touch about this modularization. I think with this, actually also what Vladimir was showing, this will be useful because at the moment, some of this can get pretty big, quite long, lots of bindings and everything. So I think it's good when it's already tested and works. But if you want to debug it and kind of try to step by step trace what works and what doesn't, where it fails, because you kind of moved from saying Tarkov to Spark or anything, this sort of having it split into different bits is also much easier to work with. Makes it easier to work with. Thank you. So yeah. I'll go through those links and also we'll be in touch, I think. Thanks.
And also feel free to write, for example, to the community group mailing list or to open an issue. That there's a lot of people, there's a good community around the tool, so maybe others have other tricks or ideas for you.
Okay. The other topic I wanted to discuss is serialization or streaming. Streaming. So Tarko is.
Sorry, Vladimir. Just a small note on the construct for quads. As far as I know, Gina, the last releases of Gina support construct quads. So we do this all the time with Spark or anything. Basically, a construct with a graph pattern, and it generates an NQ file, for example. Just a small note. Excellent. I'm not sure if this is going to be in the Sparkle 1.2. I suppose so, but I haven't checked.
Okay, let me just quickly search for the issue and whether this piece of information is related. I guess this would be the relevant issue. Andy is very active. Yeah, actually, the very first thing he says that Jena already has construct quad. Right. Okay, so that's then I'll add at the end that you guys also have it. other note. Okay,
Oh, yeah,
so the other.
And I see Justin asking if this is going to be in 1.2. That's fantastic. Okay. So yes, so we agree that we really need this. Sorry, go ahead.
Okay, so the other question is streaming. Tarko is pretty old, and now when you run it, you get a bunch of nasty warnings because just the Java libraries included are very old. But one major benefit is that it is streaming, which means that it doesn't wait for a lot of triples to accumulate before it spits them out. There is a --dedup parameter. So it's a window of how many triples to accumulate in order to make shorter turtle blocks. In other words, not to repeat the same subject for every triple, right? But to examine. But it's a limited window. And we've run it on some huge Dun & Bradstreet company datasets with hundreds of millions of rows. The only time it barfed is because it was an improper CSV. So the company Toys R Us, somebody had put, instead of an apostrophe, which is the proper character in the company name, they put a quote, and then it started looking for the closing quote, and it just ate up all the memory. Because let's say this row was row number 1,000,000, and by row number 20 million, it didn't find the corresponding closing quote, and so it crashed. But other than that, I know that this goes kind of opposite to the way that FX works, because in FX you can potentially write binds that examine multiple rows, right? You can use the previous and next functions for the RDF collection number, item number. But I think they're just like with XQuery in Saxon, for example, it is the professional versions of Saxon. There is a way to declare a high-level element in the XML and chunk it that way, right? So you don't operate, your transform does not operate on the complete XML. It works chunk by chunk in order to control memory use. So think use cases of 10 or 100 million rows. It's important not to accumulate everything in memory before you start the output.
Okay, ready for comment? So, no, I think I'm very happy because premise, a lot of the work done on Spark or anything has been applied in a number of projects, and frankly, in our case, and also in many of the people involved in the community group so far, a lot of these are small files that are distributed somewhere, many JSONs, but usually the whole input is never too large. But for a while, both Luigi and I wondered, and that clearly the full materialization approach is a limitation. So we have clearly cases where we may have very large CSVs, especially. Okay, so we are researching on different types of query evaluations that, for example, specific classes of basic graph patterns that can be evaluated with very low memory footprint. We started studying this already. And we have a prototype implementation for in the work. Okay, so of course it's not yet part of Spark or anything, but the second half of so this is something that we really are focusing on. So we hope we can have some practical solutions in the next period. But so far on Sparkle anything, there is an option for slicing a source. And we haven't really used that so much, so probably it needs some refinement. But the idea basically will be, and I think there is an open issue about that, frankly, at the moment. So this is something that we may actually cover very soon. But essentially, the idea is that you take a slicer expression, for example, a JSON path or an XPath, and then you only materialize each windowed solution. So basically, the basic graph pattern is then executed only on that window, and this means that you have a much less smaller requirement in terms of memory footprint. I think what we did for CSV is basically slicing by row so far, which I think is a bit too much and probably will slower too much the process. So what we need to do, and there is an issue open, as I said, we need to have a way to express a window so that people say, okay, now slice by, I don't know, 1,000 rows or up to this memory footprint. I don't know if this is something we can do, but making this more dynamic so that it becomes more practical for many cases. So, but this streaming is clearly a crucial issue for us. So I'm very glad to hear that this is there is need for it. I don't know if Luigi wants to say something different or something else. If anybody else has experience with.
Yeah. You have experimented this more than me.
Good to hear it. Excellent.
I can also, I think, find the issue. So maybe we can. Now, clearly, all of this is about Sparkle Anything, but everything is relevant for our FACETX community group, independently from the implementation, because clearly these implementation details have an impact on the utility of the specification. I'm recovering the slicing. Here we are. Actually, 3 weeks ago. So this is the issue about the slicing option. So and then in terms of Tarcol, I think we had a few more feedback about like Tarcol being not fully maintained, at least not in the way many users would like to. So I wonder whether there is any other feature of Tarcol that you may want to find in Sparkle Anything. I understood. I took no mental note of the like skipping duplication, because the other thing is that typically construct queries that are implemented so that the construct operator doesn't return duplicates. This clearly may be a blocker for very large graphs. So maybe people may. One thing I was thinking about, maybe some use cases may want to disable like this so that the construct just may well return duplicates, but then this may be perfectly acceptable for a number of use cases.
But I think this goes hand in hand with the slicing, right? So if you deduplicate everything within one slice and the user picks a good slice size, a good windowing size, you get the same.
Yeah, I mean, in that case, the duplication of the duplication will happen later on in the construct before spitting out the triples. So I think the limit with the slice is more about the selection. So you can't join, for example, rows that are too far ahead because you will not have them in the same graph.
Right.
That I think is the more of the limitation. But yes, the two things, one needs to play with the two features to try and get to the result that they want.
When you split the column, if you have two multi-valued columns and you split both of them, are you gonna get Cartesian product?
I'm thinking about splitting the same column.
Yeah. So
in what sense? Sorry.
So the example I gave is that in the organizations table there are two multi-valued columns, and even with
columns. Okay, no, sorry. Okay, now I understand the question. I think the way we will treat them now would be.
Yeah, you will probably have two bindings for each column. No, for each row, right?
I mean, first of all, you need two calls to Sparkle Anything. One to iterate over the rows for each row, and then another call to invoke txt transformer on a specific cell value as a content. And then this will return two bindings. And yes, you will have the cardinal product for each one of the bindings. Yes, you will have to deal with that. Because that splitting operator will be performed with the regex, I think. And then you will have to then basically, it will be as if you have one multiplied row for each value, I think, if you do it this way. Because I don't think there is any other way to split strings apart using GINA functions, of course.
Yeah, if you do it with GINA predicate functions, then you will get the Cartesian product. And there's a related problem that unless you put it in optional, you get 0 results for rows that have 0 in that column. And I think what I have done in the past is just write two transforms. One is for the single valued fields and then an extra transform for every multi-valued field. I'm wondering whether this can be done with an internal service invocation, because I know it's a great feature that you can take a string that for some nefarious reason has been is in fact JSON, but encoded as a string, and you can invoke the JSON parser on it and get the values. So maybe something like that for multi-valued columns. I'm just mentioning it because you should have examples of that, and you maybe already have.
I think I do have something. So if you either open an issue or send me an email, I'll find out.
Okay.
But I think, yes, I think the way I would do it is I would nest two transformations and then take whatever content you have from the column and find a way to parse it with the FacetX.
Okay, and then the only extra thing I can think of is this conversion of a string that is prefix name, prefix URL, into a full URL. I called it QD.
Oh, we have expand prefix name, QName. And what is, sorry, the function here? So is prefix, so it's like you go from the prefix to the namespace. Oh, that's nice. And what does it use? One of the namespace is declared in the query.
In the query, yeah.
Oh, that's fun. Oh, I think we should have that. Thank you.
No, but you can do it.
Can you?
I think that prefixes name are used. You can use it as node. So if you put, I don't know, RDF colon.
Yes, but if it's in a variable, no. If it's in a variable, no. If it's in a variable and you do the IRI function, it's going to build the IRI from the string because the variable is a string. You know?
Yeah, sure.
This is quite clever.
That's
expand prefix.
Yeah. The other point I think that we could take from this discussion is that we could also have, I mean, a syntax for expressing mappings in Turtle instead of just having Sparkle as language. I think that one point that Vladimir one point of the Vladimir's presentation was that Turtle's mappings are more readable for non-experts. So I think that
I agree.
We could take this as, I mean, suggestion for having possible multiple definition of this mapping. Also tabular for, I don't know, also other kinds of form, but since Turtle and Sparkle are two standard languages, I think we can also provide. Yeah, we in this group we define the model, the mapping functions, and so on. But then you can implement things in different languages. Sparkle, Turtle, maybe others. I think that it is a great suggestion.
Nice.
I searched with this name, expand prefix name, in your GitHub issues, and I don't find one, so I'll make an issue about it.
I'm doing it now. Fantastic.
Great.
Okay, any other question for Vladimir or discussion point? Okay, otherwise, thank you so much for joining us today, all of you. And thanks a lot for the interesting discussion. There's been a lot of nice feedback and insights that we will certainly reuse in the next work. Don't forget to register to the community group and to check out future meetings. And I hope we will have more things to discuss about in the next months, and hopefully get to a specification before the end of the year. That's our goal. Thanks so much, Vladimir. Thanks, everybody.
Thank you.
Ciao,
Thank
ciao.
you.
Thank you. Thank you
Thanks.
all.
Bye.
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 Jidoka. И ми се ми, да. Аз сега ще върна две кутии. И Ара. Ще някакъв Learn сайта.
Бързаш, може да стане и за утре.
Че тук ще е система. И ма повърна, защото това е да. Так, ще съм еро. Просто казвам, че наистина сме го получили, ама че сме го платили на това нещо.
Да. А тук в профила ти, ако цъкнем,
Не, някакси не.
да. На имейл дали не си получил на 8?
Това тя ми го е каза. Защото след като сме дали да не се да се дискутира.
Яни не знае.
Ти си
Да разпродахме се.
просто искаме по
Тихо,
официално.
само да продължим.
Това е, че ще получи там дискаунт, но просто ето за това нещо ни трябва.
Да. И препрати ми този имейл, моля се.
Направо ще го пиша на...
Здраве.
Се номера знаеш ли?
М?
Се номера знаеш ли? Или също чак аз знам,
Нашия?
компанията ги имам.
Да. че мога да ги пратя веднага на Slack, ако искаш.
Защо не ми е пуснал това?
Защо се вижда, ама...
Ще